Hi, I'm Russell Gersten from Instructional Research Group, and I'm going to talk about a model demonstration project. The project's goal was to improve algebraic reasoning of middle school students with disabilities. We did this through job-embedded professional development. This session will focus on our work in one of the three schools, and this was our first school. We were there for 3 full years. The teachers were very excited about the project from the onset and sustained that interest for 3 years, which made our job easy and which made our job easy in the scheme of things. Initially, this was the landscape when we began. The students with IEPs in math were co-taught daily in a section of math that was co-taught by a special educator and a math teacher. And we agreed to go with the flow with the structure of whatever each school did. So they did not have an MTSS model in the middle school, but rather this co-teaching model. This was what I would call informally a low track. I think it was called maybe developmental math. So it also included other students who were struggling in math, but was primarily students with IEPs. They were using, at the beginning, at the onset, pieces of grade level curriculum because they were trying to provide access to the general curriculum. And they supplemented it with downloaded Pinterest material and material from other websites. There was no screening or progress monitoring. Students took the grade level state math assessment and generally did pretty poorly. And that was the extent of data collection. Another issue that we observed was there were warm-up activities which were done to motivate students and get them interested in math, but were very, very lengthy and ate up a lot of the instructional time and were usually loosely linked at best to the content of the key lesson. Placement was by grade levels, so all the 6th graders with IEPs or math problems went 3rd period, etc. The typical range when we looked at student achievement scores in math was over 4 or 5 years. So we might have a class with students scoring between 2.2 and 7.2 in the same class, which created obvious problems for the teachers. So first steps, because we want to start with the structure, we encourage the use of a systematic evidence-based curriculum that really would cover the important concepts for success in algebra, which dealt a lot fractions, decimals, ratios, as well as help them with learning algebra. We used the STAR assessments to screen and monitor the students. And the initial scores showed, not surprisingly, 2/3 of the students were what STAR calls needing urgent intervention. Another 25% needed intervention, so there were only 8% that, at least according to STAR, needed intensive monitoring. So we definitely had the right kids in here. What we wanted to do is make these classes more functional. So we did that by cutting across grade levels and using the STAR scores as a gauge for how to place kids. So that made the classes, and the principal and the teachers were amenable to it, because that is not always the case in schools. So we were able to do that. We also then used the STAR data to create pairs so we could include and work with the teachers on peer-assisted learning. For planning, we worked with the principal, and initially we provided some financial support for this, but basically we got it so the teachers had weekly planning meetings where they could go through what they're going to cover in their 3 joint sessions. The research staff joined them just once a month. And once every quarter, we arranged for release days. So they had 8 days of professional development. The early ones were on the curriculum and use of the curriculum, use of concrete representations in middle school, which isn't done that frequently. In order to build understanding, we did quite a bit with the number line. We then, as we went into more intense, sophisticated professional development, we really tried to work on ways to keep the students engaged in the lesson. And it was an array of techniques, but we wanted the students to feel accountable. And one way to do it is we clipped out this warm up thing. So the warm up now could just be a 1 or 2 minute review of stuff. But the main thing was every student was called on every day. And this was, there was no getting off the hook. And that helped a lot. Another thing was implementation of partner activities, and then the pair, the team, was responsible for coming up to a solution to the problem or a set of problems, or together jointly explaining. Last couple of things we tried to do was encourage time for student explanations. And that seemed like it was taking time away from content, but in reality, it was the idea that kids would start to articulate how and why they did solve a problem a certain way. And the other thing we did is work with teachers on prompt cards, word walls, ways to help the students use the language of mathematics. To make a long story short, in the last few seconds, we did collect student data. This was not a controlled randomized trial. It was just a development project. We looked at pre and post in star algebra and found for 7th and 8th graders significant gains slightly higher than a random sample of 7th and 8th graders from the school, which we felt good about. There in the arithmetic, the star general math, we did not find such an impact. And with that, I'm just going to thank you, and please contact us with questions.